Next, we have a thing called power rule, which talks about how to deal with an exponent that's on the outside of parentheses. First thing you got to keep in mind when you're doing one of these problems is that if you don't see an exponent over something, there is an exponent and it's 1. That's a very key concept. Don't ever write your answers that way. It's just kind of silly. If you ever see a variable or a regular number like 3 up front, we're supposed to understand that it has a 1 exponent. But for right now, it's going to help you understand how to work with these questions. If you see the outside exponent, we're going to be multiplying that outside exponent times all of the exponents on the inside. And I'm going to draw some rainbow shapes like I often do for distributive property, because that'll remind us we're supposed to multiply across each of those rainbows, just like you do with the distributive. The result of this problem is that we get 3 to the third power, since the outside 3 times the inside 1, 3 times 1 equals 3. And then we have x to the third power. To the third power gets x to the ninth. We do 3 times 3. And then we get y to the third power as well. And that's actually all you have to do. You can work out 3 to the third power if you want to, but that's kind of your choice. You don't have to. It's equal to 27. Any calculator tells you that, but you don't have to worry about that. If you leave it as 3 to the third, you're in great shape. Take a second here, pause the video, and try the second problem out on your own. Grab some scrap paper, give it a shot. Now, the question that might have come up is, what do you do about that negative sign that's in front of the 4? That's actually going to be our difficult part of this problem, maybe also the 2 that's out in front. We'll start this problem off kind of like we did before. I'm going to put a 1 power over everything that doesn't have a power. Well, actually, that's just going to be the 4 here. I'm going to draw my distributive property rainbows. And it's really not precise of me to say distributive property, but it's very similar to it, since we're going to be multiplying that outside 2 to each of the numbers on the inside. We're going to keep the 2 out in front, as it had been before. -4 to the second power. Any negative times negative is a positive, so it becomes a positive 16. That's kind of the trap of the problem. And we get a to the 4th power, b to the 6th power. All you have to do then is multiply 2 times the 16, and you're done. We're going to keep tying these back into scientific notation as well, because we can use the properties on scientific notation numbers. You'll certainly use that when it comes to chemistry class or physics later on in high school. So this problem says simplify and express your answer in scientific notation. And we've got 5.5 times 10 to the third, and that's all to the third power. Again, pause the video and see if you can do this. The way this one will get done is that we're going to do 5.5. We're going to put that to the invisible 1 power, and then distribute your third power to both of the inside powers. Here we have 5.5 to the third times 10 to the ninth. So we actually have to express our answer in scientific notation. I'm going to need to rely on a calculator for that. 5.5 to the third power is certainly not a thing to do in your head. 5.5. Where's my exponent button? There it is. To the third power. You hit the A to the B button in Desmos anyway. So we get 166 and change. And what we're going to do is drag that decimal place to put this back into scientific notation. We have to drag the decimal 2 places to get it so that there's 1 number in front of it. Here we'll get 1.66375. Because we drag the decimal 2 places, it becomes 10 to the 11th power. And that's your answer.